So what we're going to look at today is simplifying algebraic fractions. So let's look at the first example here. This should be quite familiar from the work on indices and term 1. So let's look at the numbers first. What can we simplify here? 5 and 15, so divide top and bottom by 5, leaving me 3 on the bottom and a 1 on the top, but we don't need to write that. And then I look at my x's and x, divide top and bottom by x, so I end up with x on top, and divide top and bottom by y, so I end up with y squared on the bottom. Obviously I wouldn't leave it written so spaced out like that, so it would be x over 3y squared. So that should be pretty familiar from last topic. But let's look at this one here. What you might be inclined to try is 2 and 10, I can divide both of those by 2, so I'd get a minus 6 over 5. Wrong. Okay, we can't do that because we need to be dividing the whole of the top of the fraction by 2, not just the a part. So let's try that again, and let's just pause for a moment and look at normal fractions. When we are doing, for instance, 10 and 15, what we are doing is dividing top and bottom by 5 because 5 is a factor of both these numbers. So then I can cancel out that factor, leaving me with 2/3 in this example. So notice I used the word factor. 5 is a factor. I factorized into primes here, prime factorization from year 1. So if you look at this question again, perhaps we can use the same word factorizing, but now in an algebraic sense. So here if I factorize the top, 2 comes out, leaving me a minus 3 over 10. And now I can divide this factor, top and bottom, by 2 because 2 is a factor of the top and a factor of the bottom. So I end up with a minus 3 over 5. I divided the whole of the top by 2 and the whole of the bottom by 2. Let's do that in another example below. So here, let's try factorizing again. So let's factorize the top first. What can I take out from top and bottom? I can take out 4. It is a factor of both, leaving me with 2x minus 3. And on the bottom, I can take out a factor of 5. And that leaves me with 2x minus 3. So here we can see that 4 and the 5 don't share a common factor. I can't use that, but if we look, 2x minus 3, 2x minus 3, this is a factor. What's in a bracket is a factor. This is 4 multiplied by this and 5 multiplied by this. So I can divide top and bottom by 2x minus 3, which leaves me with 4 over 5. In effect, I have cancelled in the same way we did with the fraction earlier. So this means we can use our algebraic factorization to help us cancel fractions. Now let's look at this next example. I would start off factorizing the top as normal, 2, a minus b. But you might notice that that doesn't match anything on the bottom as it currently stands. A minus b is not on the bottom, but there is b minus a. So what we're going to do here is find a way to rewrite that as a minus b. What would need to go outside the bracket? Minus 1. But I can just put a minus here. This would be minus 1 times a, which is minus a, and minus 1 times b, sorry, minus 1 times minus b, which is positive b. So this is the same as this. And now these match. A minus b on top and bottom can cancel, which would leave me 2 over minus 1. 2 divided by minus 1, which I would write as just minus 2. Okay, so that covers all of our examples now. We'll just do one more that mixes some of those ideas together. Okay, so here we don't have any sort of nice number factors on the top, but it's already been factorized for us. X plus 7, x minus 2. And the same for the bottom has already been factorized. Let's look at what we can simplify here. Well, I can't divide the top by 2, there's no 2 as a factor. I've got x plus 7, x minus 2, and on the bottom I've got x plus 7. So that means I can cancel x plus 7 with x plus 7, but let me just show you what that would not look like. It would not leave us with x minus 2 over 2 squared. I have seen someone do this. Okay? I'm not just getting rid of the x plus 7, because I need to remember, what does x plus 7 squared mean? This means x plus 7 times x plus 7. So if you imagine this was in the bottom of that fraction, if I cancel this, I only cancel one of these away. So on the bottom, what I have left is 2x plus 7. I've cancelled x plus 7 from the top and bottom, but I still have 1x plus 7 on the bottom of this fraction here. And that is all. That concludes the lesson on simplifying algebraic fractions, and next lesson we'll look at multiplying.